So logic and mathematics are two sister disciplines, maybe, because logic is this very general theory of inference and reasoning, and mathematics, of course, is, reasoning and inferences play a very big role within mathematics, because that's mathematicians, what they do is they prove theorems, and to do this, of course, they have to use logical principles and logical inferences. They have to make reasonings. Okay. But the story of the relationships between logic and mathematics started with a very philosophical question, which was asked by Kant in his famous critique of pure reason, which is whether there is more to mathematics than just logic, or whether mathematics is just about logic, just about our general ways of doing inferences. Okay, because in what I said at on the basis of what I said at the beginning, you could think that, well, maybe there is nothing more to mathematics than logic, because mathematics is just an instantiation of our general ability to use, to do proofs. Or you could say, okay, of course it matters to mathematics that we use that we do proofs and that we use general valid principles, but there is more to mathematics. For example, there is some sort of intuition. Okay, when you're a mathematician, you don't just do abstract proofs, you have this sort of vision in a metaphorical sense or intuition of the kind of objects you're talking about, and your results, your theorems, they are they are grounded in this intuition. So you could have this sort of purely formal view of mathematics as based on purely logical principles, or you could think that there is something like mathematical intuition, maybe to access a Platonic realm or something else, which is needed on top of logical principles to build mathematical theories, to get theorems. Okay. And the take of Kant on this issue was that the first option cannot be right, because if we just look at the concepts, at mathematical concepts, and there is not enough in them to ground mathematical truths. Okay, so he took this famous example: how do we know that 7 plus 5 equals 12? And he says, well, if you look at the concept of 7, if you look at the concept of 5, and if you look at the concept of the sum of two numbers, then nothing is going to tell you that this is equal to 12. And somehow you have to produce, to generate that truth, for example, by counting on your fingers, and that would rely on some sort of intuition. Okay? So, but then Kant went on, this cannot be just, the fact that this cannot be just empirical intuition, because the fact that 7 plus 5 equals 12 does not depend on how your fingers behave when you count with them. Okay? So then Kant developed this very sort of complex account of mathematical intuition, which is neither Platonic, because Kant did not believe we could have intuition about a realm of objects which would be inaccessible and inaccessible from us, like in a Platonic sky, and which was so a kind of intuition which was neither Plato's, neither empirical intuition, because he thought that mathematical truths were not about fingers or little pieces of sticks that we use to count. And okay, he came up with a notion of mathematical intuition as an intuition of space and time, but the solution was very clever, but maybe it was too clever and too intricate, so people were a bit worried about that being artificial in some sense. And then another philosopher and mathematician, Frege, came up and said, well, but is it so sure that we need more than logic to show that 7 plus 5 equals 12. Okay? And they said, well, Kant has this very weak, this very poor view of logic that it's just, developing what's already in our concepts. But actually, there's more to logic than just what Kant thinks there is. Logic is also a way of thinking about relations, about all kinds of abstract connections between concepts, and it's not just deploying them in the way Kant thought it was. So Frege said if we have a broader view of logic, if we try to provide a systematic understanding of the abstract connections that there are between concepts and of the ways in which we can define new concepts, maybe we will find out that Kant was wrong and that there is no extra mathematical intuition which is needed to prove that 7 plus 5 equals 10 or any other mathematical truth. Okay? So that's the basis of the debate about logic and mathematics, namely, is there more to mathematics than just logic, and do we need something like mathematical intuition or something like that to account, to ground mathematical truths? And so Frege thought that Kant was wrong, and he tried to prove that Kant was wrong. And he tried to do two things to do this. First, to build a general system of logic more powerful than the logic that Kant had inherited from Aristotle. And he tried to, that's the first thing, and the second thing was to show that on the basis of that general system, which he called the basic laws of thought, that on the basis of that system, which was more powerful, more rich, more subtle than what the Aristotelian tradition gave to Kant, it was possible to do what Kant thought was not possible to do, namely to prove mathematical truths, in particular arithmetical truths, just on the basis of logic alone. Okay. And it took him years and years to do that, more than 20 years, and in 1904, Frege was ready to publish his masterpiece, showing that indeed it's possible to do these two things at once. But just before the book was published, he received a letter from a famous logician and philosopher called Bertrand Russell, who showed that the system by Frege was inconsistent. Okay. So showing that the whole work of Frege's life was a failure. And this was dramatic, but since Frege was a rigorous mathematician, he admitted that his system was inconsistent and well, that things were more complicated than he thought it was. So then, what in order to adjudicate this debate between this dispute between Kant and Frege, logicians and philosophers tried to salvage Frege's system from his inconsistencies and to come up with systems which would be as powerful as Frege in the sense of being able to derive mathematical content, so stronger than just good old Aristotelian logic, but of course not inconsistent, not faulted the way Frege's system was. So various systems were developed to do that. One of them was the Principia Mathematica by Russell himself, Russell and Whitehead. Another one was set theory developed by a mathematician called von Neumann. And they did this, and they were reasonably successful in this. That is, in being able to come up with systems that would account for almost all of mathematics and which did not contain any inconsistency, easy to spot, at least, the way Frege's system had one. But when they did this, the result was some sort of blurring of the lines between logic and mathematics, because in order to succeed, they needed to put axioms, principles, in their logical systems which were not so clearly logical anymore and which were a bit borderline themselves between logic and mathematics. So for example, if you're doing set theory, you have a rich theory of sets which can account for all the structures like the natural numbers that mathematicians study, but you need an axiom of infinity, what mathematicians, set theorists call the axiom of infinity, which tells you that there is an infinite number of objects. Okay, and if you don't have that axiom, then you cannot do your business. Okay, but then the problem is that this axiom of infinity, it tells you that there are objects which exist and that there is an infinite number of them. And in a sense, telling you which things exist or how many things exist, it's something substantial which should not be, which is maybe not the business of logic. You would think of logic as being neutral with respect to how many things there are or what kind of things there are. Okay. So the upshot of the attempts to rescue Frege's system from its inconsistencies were successful theories, like set theory, but theories which were successful from a mathematical point of view, but which were less successful or less convincing from a foundational or philosophical perspective, because it was not so clear anymore what belonged to logic and what belonged to mathematics, and whether you were successful or not in getting rid of mathematical intuition on the basis of these technical achievements. So you could say that this is because, to start with, you do not have a clear notion of what are the borders, what are the frontiers of, respectively, logic and mathematics. Because in a sense, both Kant and Frege took for granted that we know that logic is about, basic inferences such as modus ponens, basic theory of concepts, such that the idea that whenever you have a concept, there are the objects to which that concept apply, and so on. So they relied on an informal, not very precise notion of logic in order to, in their attempt to show or to disprove the fact that maths was just about logic. And so, in a sense, what was revealed by the work of Neumann, Russell, and all the other people who developed systems after Frege was that it was not enough to rely on an informal understanding of the limit between logic and mathematics, and that more needed to be done, more philosophical work needed to be done to understand what is a logical concept and what's distinctive of logical concepts among all the other concepts that we use, that we think, towards which our thinking is directed. And so that it's only when you have achieved a proper understanding of what's specific with logical concepts that you could answer the question about the relationships between logical concepts on the one hand and mathematical content on the other hand. And that's nowadays a very lively debate within the philosophy of logic and mathematics, which is to try to understand, to better understand these limits, and that is what makes a concept such as conjunction or notions such as, what you express when you say that all cats are mammals, for example. What is the concept which is expressed by all, and what makes that concept logical as opposed to empirical or mathematical?